Hello everyone. So today I want to talk about the Apple M chip. So why the M chip, M family chip is so powerful and the energy consumption is so low. So I want to discuss this problem in three ways. So the first one is about the SoC. The second one is about its memory design, and the last one is the operating system optimization. So the first problem is there existing a contradiction between the flexibility and the peak performance. So as we know that today's CPU, they support hundreds of instructions, but in order to run some instructions, you need to execute the entire pipeline, including fetch the instructions, get the data, branch predictions, out of order, scheduling, execution, and so forth. So even though for the very short pipeline, uh, some processor of x86, it needs to run 10 to 20 levels of instructions. So the problem of such design is that if you need to run a lot of data, so every instruction need to get involve so many instructions, and also the hardware transistors, and which will consume lots of power. And so as you can see from the following figures, so for the non-computer heavy applications, only 6% of the energy is consumed on the real execution. For the modern CPUs, in order to address such problems, so there are two ways. So the first one is called the instruction combination, which means we just use the hardware to run this most formal computations. So for example, if the algorithm needs five instructions to run so that we can design a specific circuit in the hardware so that only need one instruction to run it. And it called the instruction combination. Just use the hardware solution. The second solution is called SIMD, so single instructions, multiple data. So the purpose of it is just to use a single instruction to run not just one piece of data, but a bunch of pieces of data. And so that we can save the pipeline, energy consumption, and it can improve a lot compared to the old design. However, even we have the existing optimization, the CPU pipeline is still way more complicated than the GPU. So in order to achieve high efficiency, and the CPU will use more level instructions. So in terms of the energy for the same workload, the CPU energy consumption is far more than the GPU, other than the DSP or NPU or others. So that's a problem for the CPU, the contradiction between the flexibility versus the peak performance. So second, let's talk about the memory performance. So for the memory, basically it has two parts. First is latency, second is the bandwidth. So for the modern memory, so in order to reduce the latency, so the machine usually prefer to use large cache. So as you can see from the following figure, so the L3 cache compared to the main memory is the bandwidth is 8 times faster, and the latency is just 20%. But the large cache, it also has the cost because it will consume lots of transistors and hardware and different connections, and this will consume a large amount of energy. And for the bandwidth, it's the same thing. So last but not least, let's talk about the I/O. So for the modern PC, some CPUs they have the internal GPU, integrated GPU. Some other has external GPUs and other accelerator. So in order to achieve the best performance, so we need a high I/O connection between different components. So, but we have such kind of cost for this complicated I/O. So first, the cost is more compared to the integrate, hardware. And second is there exists a large amount of data copy between the CPU memory and the GPU memory and other, memory. So there exists so many data copy duplicated, and this also slows the entire system performance as well as introduce more energy cost. So after talking about the problem of existing processor, so next let's just take a look at how Apple Silicon, the M family chip, deal with the above problem. So first, as you can see the following figure, this is the design of Apple M1 chip. So beside the CPU core, so we also have the GPU, the neural engine, the memory controller, the I/O controller, and also specific processing unit, such as the image processing, video decoding and encoding, video processing, audio processing, and all these specific units, they can process a large amount of data. And also this specific circuit, they can process the data without the pipeline of CPU, which can consume very little, power consumption. And for the CPU part, it only responsible to core the corresponding process unit, and then just calculate the data in certain memory, and that's it. So that's the unique design of the Apple M family chip. So the second very unique design of Apple chip is a unified memory, as you can see from this figure. So the M chip, it has two DRAM part, you can see. And the CPU, GPU, neural engine, and other units, they can connect to this DRAM through unified bus and connect the DRAM as well as the cache. So on the one hand, it can very effectively save the memory bandwidth requirement because it's very large, 8 gig or even 60 gig. On the other hand, you can see the unified cache can also save part of the memory bandwidth and reduce the memory latency. So last but not least, because for the above two, the other manufacturers such as Qualcomm can also design such a SoC. But the unique advantage of Apple is they also control the operating system. So based on the Apple's website, the macOS has unique data access for all the different hardware units, such as GPU, the video decoding, the media engine, and so forth, so that the different specific unit, they can directly use the other unit generated data because it's a unified format. And then different parts, they don't need further data copy or additional transitions. And compared to the other SoC manufacturers, they need to support a different kind of operating system or the same OS but different version, okay? And so it's very hard to optimize the software for the hardware. But on the Mac, all the applications only can be compiled by Apple's compiler and developed tools, and use Apple provide unique APIs and framework so that the application level, the software can further, take advantage such kind of hardware design. So last but not least, because every coin has two sides, so let's talk about the problem for the M chip. So the first problem is the flexibility, because when you buy an Apple chip, so such kind of specific unit cannot be modified anymore. So in the industrial, if we have a new figure format or video format or new algorithm, so the Apple hardware cannot support the new stuffs. And the second problem for the Apple chips is the customization. So because the Apple chips, when you buy it, everything is set. So you cannot like replace a piece of memory or extend another hardware based on that. So that's another problem for the Apple M chip. So the lifetime for such kind of chips may be very short compared to the other, PCs or hardwares.